Cool. Thanks, guys. Well, thank you again. Sarath reached out to me on LinkedIn. I remember like a month or two ago, and sort of said, "Hey, we're looking for more speakers for this event." And I said, "Well, if it's for all levels of machine learning, I got to talk." And I will apologize now because I did do a version of this at DDD Brisbane last year as the closing keynote. So if you were at that event, you might recognize some of the content, but hopefully it'll still be interesting to you. So as I mentioned, I was a developer in my past life. Nowadays, I'm at AWS helping folks learn how to take advantage of the cloud. And so this here I'm going to talk to you about is my first ever machine learning project. So be gentle. This is not my area of expertise, but it's been super fun to learn. And I'm very lucky in that I work with some very smart people who gave me some very good advice. And that's what I'm hoping to pass on to you all today, especially people who are just starting out. And the other thing that you should probably know about me, and you've probably figured out by now, is that I'm a knitter. I have won actual blue ribbons for my knitting at the Sydney Royal Easter Show. I have already finished one isolation jumper. I have like 3 different knitting projects in arm's reach of me right now. And yes, I have seen all the memes. You don't need to send them to me. I get these all the time. And more importantly, that's crochet, people. That's not even knitting. Bunch of muggles, right? But yes, I am also a geek. And I really love to combine these two passions. In fact, I was saying before we started, I have actually been knitting the COVID-19 genetic sequence into a scarf. There's a better image of it. So I actually went to the CSIRO website and downloaded the nucleotide sequence and started knitting it. Each letter corresponds to a color, and that's how many rows I knit. David asked me before we started if it was going to be long like Doctor Who. So I actually calculated out based on the sample I grabbed, which was not even remotely near the full sequence. At the gauge I'm knitting, this scarf would end up being 45 meters long. So no, I'm not knitting the whole thing. I'm just going to knit until I get bored or until we finally all get back to normal, whichever happens first. Yeah, knock on wood. So anyway, yes, I am a knitting geek. And my friends, I have a dream. And my dream is to invent a knitting replicator. Okay, I'm going to give you the scenario here. This is the use case. It's a crisp autumn day. It was quite cold today in Sydney. I don't know about up in Brisbane. I'm walking through Sydney and I see someone in an amazing jumper. And of course, I ask if I can take a photo because that's what knitters do. And I'm not a creep, so I ask permission. Well, let's imagine that I've taken a picture of this girl's jumper. And ideally, what I want to do here is I want to take this photograph. I want to feed it into some sort of, a knitting replicator machine. And the end goal is to get out a jumper for me, to actually reproduce it. Very Star Trek, this kind of version, right? I mean, let's even pare it back a bit. As a knitter, I'd even be happy if instead what I got out was this, the actual pattern that I could then knit from. And maybe this seems totally far-fetched to you. It seemed really far-fetched to me a year ago, but hey, I grew up in America. Overconfidence is my birthright. And there have been some actually really cool breakthroughs in the fields of knitting and machine learning in the past few years. Breakthroughs that, believe it or not, could actually completely disrupt an industry that's literally existed for millennia. So that's kind of just to set the context of what we're talking about today. So just to get a baseline, does anyone here other than David knit? Have any of you ever knitted as kids or anything? Just put your hands up and I'll scroll through the pictures and say. Maybe a couple. All right. Well, do not worry. No knitting experience is necessary. I am not going to teach you to knit, nothing like that. This is in fact what I'm going to cover. So just quickly, the first part of the talk, I'm going to talk about why I think knitting and programming go really well together, just geeking out a little bit. I'm going to talk about embedding data in textiles, some really fun little things. I'm going to talk about knitting machines and DSLs, which is kind of the right-hand part of that diagram of my knitting replicator. We're going to talk about simulating knitting and some of the cool digital manipulation you can do. And then we're going to talk about reverse engineering, because in order for my replicator to work, I actually need to reverse engineer the pattern from the image. And then we're going to talk about my knitting ML project. And actually, I'm not going to do the lessons from the knitting community. You guys don't need to hear that bit. We want to spend more time on the machine learning. All right, so embedding data. The cool thing about knitting is if you've ever done it, you know that there's only 2 stitches, knit and purl. And so it's inherently binary. So I can knit any digital file using knits as the ones and purls as the zeros. This scarf here, for example, is the source code to the website Ravelry, which is pretty much GitHub for knitters. You know, it's like a big catalog of patterns, projects, and yarns, but it's also a social network. And so this knitter actually converted the homepage HTML into binary and knitted that into a scarf. Now, if you're more of a black hat, your brain has probably jumped ahead and realized you could even knit a virus this way. So way back in 2001, a team of activists at the Viral Knitting Project, they did that. They knitted the source code to the code red computer virus into a scarf. No firewall is going to pick that sucker up. Now, in fact, the scarf I am wearing right now, this one, is actually malware itself, quite literally. It comes from the artist Jeff Donaldson. He goes by the name Glitch House, and he sells a range of scarves and homewares that he calls malware, get it, where, that encode famous malware. And this scarf is actually the I Love You virus. If any of you were old enough to be on the internet back in 2000, that was a fun day. I remember that day. Yeah, I have it knitted into a scarf. He's even got Stuxnet as a throw if you need something to put on the back of the sofa. So he clearly uses color to encode his malware, which is a very popular technique. I used it myself to design a pair of QR code mittens. And these were in the Easter show a few years back. They were surprisingly difficult to get to work. The biggest problem is that knitted stitches are rectangular. They're usually wider than they are tall. And QR codes really need everything to be quite square in order to work. So I had to basically stretch the hell out of it to get it square so it would work. But this one does actually work. You can actually scan it, and it goes to a URL for a site that has the pattern for the mittens. So they are, in fact, self-replicating mittens. Now, a related field that's gotten attention in recent years is data art or information art, and that can be knitted too. This is just some fun little entertaining stuff. You may have seen this one go viral last year. This German woman, Claudia Weber, she knitted a scarf to track the delays on her commute home to and from work every day. So every night she'd knit 2 rows, gray for delays under 5 minutes, pink for delays up to 30 minutes, and red for delays over half an hour. So as you can see, Claudia had like a really bad month there. And she eventually auctioned this scarf off on eBay and raised money for a German charity that provides assistance to people at train stations. This is another one I really like. This is a group of radical knitters started the Tempestry Project, which is all about assisting climate change discussions by scaling the problem down into something accurate and tangible and beautiful. So each of these, they call them tempestries. It represents the daily high temperature for a given year in a given location, with January at the bottom and December at the top, all using the same yarn colors and temperature ranges. So as you can imagine, these are going to start to get more red over the years. And the website actually has instructions and kits for making your own if you want to document a year in your own particular location. This is a project I loved. Speaking of geeky knitting, it went viral last year. Seung Lee, this guy, it's a sleep blanket documenting the first year of his baby son's sleep patterns. So he collected all this data by manually, I don't have kids, but apparently there's apps where you can record like when they go to sleep and stuff. And so he manually logged it in an app, and then he used JavaScript and Python to convert that into a visualization. And he built a little browser-based tool to keep track of the stitch colors and the pattern. And he knitted this blanket. So it's 185,000 stitches. It took him more than 3 months to complete. And each row is a single day. With the top row there is the day the baby was born, and the bottom row is the baby's first birthday, with each stitch being 6 minutes of the baby's life, whether he was awake in gray or asleep in blue. And I just think it's a really, really pretty thing. And just one last one I really like. This was the Neuro Knitting Project. So this guy took a wearable EEG on your head and used it to record users' affective brain states while listening to a piece of music, Bach's Goldberg variations, and then knitted that into a scarf on a hacked knitting machine. So he is in fact wearing his own brainwaves there. So if you did not know that knitting machines were a thing, they totally are a thing. They've been around for a long time. Hacking them has gotten popular by knitting geeks in recent years. Some of them used punch cards I've actually seen those at some knitting events, punch cards to input patterns. Others were computerized and had like built-in stitch patterns. Some of them had floppy drives or special cables for plugging into your computer. So hacking them these days usually involves making your own serial cable and using software to transfer new custom designs to the machine. There's actually an open hardware project called Knittic that uses an Arduino as a new electronic brain for the machine, and that allows designs to be manipulated on the fly. This is really cool. I found one on Gumtree, one of these machines, and got really excited that I would be able to hack it, and somebody swooped it up before I got to it. But this is one that's actually working. So my friend Sarah Spencer, she's a developer in Melbourne, and she turned this dumb 1980s knitting machine into a wireless knitting printer using a Raspberry Pi, an Arduino, Python. She designed and 3D printed that bit on the front, which is a custom color changer. And she developed a multicolor algorithm to allow her to use 3 separate colors in a given row. She actually, I don't know if you can see behind me hanging up, there is this Hamilton blanket. She actually knitted that for me on this machine. And she actually also used that setup to create this artwork, which is called Stargazing, a knitted tapestry. And that's actually her sitting on the right side there for scale. It's 4.6 meters wide by 2.8 meters high. It's a star chart of the visible galaxy. It used 15 kilograms of wool. And she presented a tech talk on this at EMF Camp in the UK a year or two ago. And so you can actually look that up if you're interested about it. It's just a really cool project. If you want to make your knitting replicator and you don't want to hack your own machine, there are other options, interestingly. A bunch of people sent me this one. This Knitterate was on Kickstarter in 2017. The idea was to bring affordable, easy-to-use professional knitting machines to everyone. Because there are industrial knitting machines, of course. They cost like 50 grand. And so this Knitterate machine was going to retail for like 7,500. And so they started manufacturing these last year, and they've begun shipping. So I'm quite keen to see what effect they have on clothing production. I do not have one myself. They're actually quite big. Like they had like a sort of rendering of one in it with a person standing next to it. And I was like, crap, my little house in Sydney is not big enough for that. So I don't have one yet. But anyway, the knitting part of my knitting replicator is a solved problem, pretty much. So the bigger problem for my little dream project is how knitting patterns are actually specified. Turning a picture into a pattern, and then a pattern, I can feed a pattern into a machine. But the thing, there's just no off-the-shelf software that does that. And so what you really need is you need a domain-specific language. In order for knitting patterns to be shared and reused, to be understood by a machine, you need a standard way of expressing knitting patterns. Now, actually, these have existed for a really long time. One of the oldest ones were the binary punch cards used on the Jacquard loom way back in 1798. And so this French guy, Jacquard, developed a system that allowed punch cards to control the operations for this loom. I actually saw one of these working in Geelong. The Wool Museum in Geelong, Victoria has one of these. And just before isolation, I actually went there and got to see one of these working. But anyway, he invented it. And 40 years later, Charles Babbage saw it and went, oh, hey, that would be kind of cool maybe for that proposed computer thing I'm thinking about, his analytical engine. So yeah, and they're still used for knitting machines today, well into the 20th century. But the other way, the way you're probably used to seeing knitting patterns expressed is text. But hate to tell you non-knitters this, there is no standard. Everybody writes them differently. You see, this pattern actually has to have like a bunch of lines just explaining what all those abbreviations actually mean. So I can't just give this without those explanations to another knitter and expect them to understand it. This is the equivalent of assembly code, more or less. So another way patterns are expressed is knitting graphs. This is a symbolic expression of a pattern, like a visual programming language. So charted patterns tend to be more concise than writing them out in words. You can get a lot more information crammed in there. There's still no standard, but this example here, these symbols are pretty widely used. And the cool thing is they kind of look like what they represent. Like those O's, those are a yarn over, which makes like a hole in the knitting. And that like chicken foot symbol is like a decrease that takes 3 stitches and combines them into 1. So this abstraction has a lot of information. It's got like 9 different pieces of information in a very small space. But that orthogonal grid is really rigid, and some knitters and computer geeks think we could do more to represent knitting accurately in a domain-specific language. Enter stitch maps. So these are a knitting pattern visualization that let you see how parts of the pattern fit together over time. So not just the sequence in a given row, but how they interact from row to row, like with increases and decreases. So for example, this particular pattern is called feather and fan. And when you knit it, it actually results in a wavy piece of knitting like you see here. And the cool thing is this is actually compiled. Stitch maps are compiled from a domain-specific language called KnitSpeak. So you can go to the Stitch Maps website there and enter a pattern that looks like this, and it will compile it into this, which gives you a much better idea of what the fabric will look like and how it'll behave. And so this is cool. This starts to look like something that maybe I can use for my knitting replicator. And they're also industrial knitting machines. Remember, I mentioned those, and they have DSLs as well. So Shima Seiki, they make these really expensive industrial knitting machines, and they provide design software companies can use to program them. So you see here that image on the right, that is their DSL. It's a visual DSL with both symbols and colors. And that on the left is actually a simulation of what the finished textile will actually look like. This is another screenshot. This is software for Stoll knitting machines, another brand. And so this is really serious stuff. Like you're basically implementing your pattern in a machine language that can be simulated and fed directly into the knitting machine. And I'm told that when you buy one of these machines, you actually usually fly to the factory in Germany for several weeks of training, just so you know how to use the darn thing. That said, there are some fun niche ones, open source ones. It looks to be a popular project, like for computer science students who also knit, to try and invent and build their own compiler for it. So I found a couple. This is one I found called Pearl that Chelsea Corvus did in 2016. It uses notation similar to traditional knitting patterns, but it kind of has some like syntactic sugar to allow your patterns to be verifiable. And she's got a tool on her website that demonstrates it. So here on the left is a pattern written in Perl. And then when you hit compile, it generates the pattern on the right, which is more traditional looking. So her syntax is shorter, and it allows you to sort of just tweak some variables and regenerate patterns without having to redo all the math, which is really cool. Now, one of the more serious attempts to open source a knitting DSL was KnitML. And I've talked about this in a few talks over the years, and people always laugh. Yes, KnitML, it was really a thing. It was an open source project from 2007, and the goal was to make a standard markup language for knitting patterns. Laura Porter had noticed that patterns tended to be written, like I said, in all kinds of non-standard styles and abbreviations. And so this was, the idea was this of KnitML was to promote a new international standard for knitting pattern expression. But it only expresses the content of the pattern, the steps required to produce the item. It doesn't actually specify how the pattern is to be laid out, similar to HTML. So this is what KnitML looks like, and it is not concise. It doesn't look much like a traditional knitting pattern. But remember, this was meant for computers. This was an intermediate format for pattern exchange and transformation. She did not expect that human beings would actually go in and directly manipulate this. Instead, the project had a pattern authoring tool called Knitting EL, which was knitting expression language. This was supposed to be a simpler way for designers to write a pattern, and it looks sort of more like a traditional knitting pattern. And the project, you have to go to archive.org to find it pretty much these days, but it had Java-based software to convert knitting EL patterns to KnitML. And so, like I said, it hasn't been actively maintained. I have managed to find a few folks through doing these talks who are interested in helping me revive it. So, you know, you never know. Okay, so let's bring this back. What is the point of doing this? What is the point of standardizing the way we write knitting patterns? Well, it allows really useful operations. Like with that Perl compiler, you could just tweak some variables and generate custom patterns, which is great, instead of having a designer having to design all the different sizes you'd need. You could write patterns that could be compiled for different thicknesses of yarn, because that matters if you change how thick the yarn is. A compiler could output charts or text, whichever the knitter preferred, English or metric measurements. It allows for unit testing. So many patterns get published with errors in them, and you could actually have verifiable patterns and have a CI/CD pipeline that would check for errors and let you know if there were parts of the pattern that were unknittable. And the other really interesting thing, and the thing that makes it relevant to my knitting replicator, are simulators. You know, we've seen that the really expensive industrial software can do it, but so can open source ones. So this was one called Knitter I found that would take that KnitML pattern and produce a 3-dimensional model of the resulting knitted fabric. And so again, this isn't abandoned, but if you write C, please go and revive it for me. And this got me thinking, like, you know, if I can take a pattern and simulate the end result, you see where I'm going. I want to go the reverse way. And I found a bunch of white papers for people who are taking simulated knitting even further than this. This was a paper from SIGGRAPH 2012, which is an annual computer graphics conference. Because the idea is that as CGI characters get more and more realistic, their clothes have to look more and more realistic too. And the usual way they do clothes for computer generated actors is to just take like a thin sheet and print a texture on it. And that works fine for like cloth, but it doesn't work for knitting. You know, knitted garments kind of have like a 3D structure. And so these computer scientists from Cornell University, the University of Utah, and Facebook randomly, they came up with this idea for stitch meshes. That's what they called them, which was kind of another a visual representation of knitted stitches that could be combined in different ways and even relaxed to look more realistic. And so these are a collection of samples. So on the left, I'll highlight, for example. So on the left is their stitch, on the left? Yeah, on the left is the stitch mesh. So this is the graphical representation of it. It uses color and shape to designate different stitch topologies. The middle image is a simulated image. So that's not real knitting. That's a computer simulation of knitting, taking that. And on the right is a photograph of real knitting. So you can see how close they've gotten. And they're getting pretty darn close in some of those examples. This is a paper from 2018, Knittable Stitch Meshes. This builds on that earlier work. And the authors here thought, well, if I can design realistic looking fake knitting in a computer, why not take it a step further and turn that into a knitting pattern? So we're getting closer to my replicator here. So they built a 3D design interface, and through that, I can design an arbitrary 3D knitted shape, and their system will then work out how to turn that into a knittable pattern with minimal seaming. So that's really cool. That opens up a whole new world of 3D knitting design. And again, it's getting us closer to the knitting replicator. These examples all have a really smooth texture though, and I like stitch patterns. So this paper, Nitpicking Textures, this was published late last year by the Carnegie Mellon Textiles Lab. And so these scientists have built a workflow that takes a KnitSpeak file, and remember that was the one from Stitch Maps, and it looks pretty much like a traditional knitting pattern. It compiles it into what they call a knit graph, which is a directed graph where nodes represent loops with yarnwise and loop-to-loop edges, and that graph can then be manipulated by the computer. They provide some methods like carving, which allows for resizing a piece of knitting while respecting texture. Because, you know, let's say you have a pattern that's like 40 stitches by 40 stitches. If you want to knit something smaller, you can't necessarily just cut off part of the design. And they've also invented a method of patching that allows different textures to be combined together and keep the same shape, because some bits of knitting pull in from the sides or from the top. And so it actually allows you to keep the shape by combining different patches. And so once you've done all that manipulation, you can then compile it back into KnitSpeak instructions that someone can knit. I bet you never realized how many computer science papers there are about knitting. So this is why all of this got me thinking that my replicator might be possible. After all, if we can take a traditional knitting pattern, we can turn that into a standardized symbolic representation of an algorithm. We can then take that and turn it into a simulated physical object, as well as an abstract representation that you can manipulate in different ways. That would be really difficult for human knitters and human brains to do. And then take that and turn it back into a traditional pattern that a human being could turn into a real tangible object. Why couldn't I go the reverse? Why couldn't I go the other direction? Really, it's about, can a computer be trained to read knitting? This is the question that has obsessed me for 3 or 4 years now. And so this is where we're really getting into the machine learning part. And I'll explain what I mean by reading knitting. This is a photo I took of my colleague's jumper in our office last August. And like I said, I'm a knitter. That's what I do. And I saw this stitch pattern. I'd never seen this stitch pattern before. And I took a photo and looking at it, I can tell you, and I'm sure David can tell you as well, the background is reverse stocking stitch. And those raised zigzag lines, those are 3 knit stitches, and they use decreases on one edge and increases on the other. And that's what makes them lean to the sides. And some of that I get from recognizing the texture and knowing how stitches work. But I could also zoom in really close and read it stitch by stitch, kind of like deciphering cursive handwriting. And that brings us to reverse engineering, which is taking a human-made object and studying it to deconstruct its design and architecture. And you guys know we do this all the time in software engineering. But it's actually something knitters do all the time too. We love doing it. So I just give you a couple fun examples. This is an example from 2009. A knitter was looking at the Shetland Museum Photographic Archives. This is a museum in the Shetland Islands, middle of nowhere, right? And she found a photo of a lace shawl from like 1890 something. So she put a photo of this on Ravelry, as I mentioned, which is like GitHub, and said, hey, does anybody recognize this border? Eventually, this turned into a mammoth project involving more than 30 different knitters all around the world, spending hundreds of hours reverse engineering this from a photograph through trial and error. And they got in touch with the museum to find out more about the family. And once they recreated the pattern, they actually released it under a Creative Commons license for free. So you can actually knit this yourself if you want. And I just love that idea that a piece that was knitted before the turn of the century, designed by someone in a very isolated area and only preserved in a photograph, has been recreated by a bunch of people brought together by technology and a love of this craft. I just think it's really cool. And in fact, forensic knitting, as it's called, can be really important for actually preserving history because a lot of patterns weren't written down. This is one, oh God. So in 2003, a knitter named Leah Stern, she visited the US Holocaust Memorial Museum in Washington, DC, and she saw this little green sweater, which was knitted for a 5-year-old girl by her grandmother in 1941, Kristine Howard. And when the girl was 7 in 1943, she and her family had to hide in the sewers below their home in Poland for 14 months to escape Nazi persecution. And this sweater was one of her cherished possessions, one of the only things she was able to take with her. And thankfully she survived and she made it to the US, and years later she donated her sweater to the museum. And so Leah Stern, this knitter, seeing this piece in the museum, she thought she had a duty to try and re-engineer the pattern for it so its history would remain alive. So she got permission to examine the original sweater closely. She took measurements, she took photographs. She couldn't find this particular stitch pattern anywhere. It was in no known book. It might have been that Kristina's grandmother actually made it up. But she was able to recreate the sweater through her research. And in 2014, she was able to present the finished recreation back to now Dr. Kristine Howard, an old woman who held it up and said, now I have my sweater back. It gives me chills. And you can actually buy that pattern on Ravelry or at the Holocaust Museum bookstore. I just think it's so cool. And this is actually from my own collection, a bit closer to home. Sir Douglas Mawson, who was on the Australian $100 bill for a while, one of Australia's most famous Antarctic explorers. This photo of him in his famous balaclava, that's the photo that was on the money. His actual balaclava has been preserved by the South Australian Museum. And in 2014, master knitter Leanne Gould reverse engineered that pattern and published it. And my friend Ted bought me this pattern, and I am supposed to, oh, it's cold right now. I need to get knitting on this because Ted needs a balaclava. Okay, so a skilled knitter can reverse engineer a pattern from a finished article or even just a photograph of a finished article. Then why the heck can't I train a computer to do it? So this goes back to where I told you all at the start that my practical machine learning knowledge before starting this project was a big fat zero. It was basically just XKCD cartoons. I'm sure none of that is particularly new to all of you. But as I said, I work for Amazon, for AWS, and I have some very smart and generous colleagues. So I took one of them, Aparna. She's like a PhD in this stuff. I took her to lunch last year. We're sitting at grilled over burgers. And I was like, hey, I want to train a computer to read knitting. And she went, oh, somebody's just done that. I'm like, well, crap. And so she sent me this paper. Neural inverse knitting from images to manufacturing instructions. It was presented at the International Conference on Machine Learning in June 2019. So basically these guys were trying to build my replicator. They wanted to take a photograph of knitting, reverse engineer the pattern, feed it into a knitting machine, and get the same knitted swatch back out. And by swatch, I mean just like a bit of knitting, a piece of fabric. They wanted to build my duplicator. One of the key breakthroughs they had early on in the project is they realized that photographs of knitted fabric suck for computer vision because knitting it's floppy, you know, it's stretchy. Depending on the wool you use, it can be fuzzy. So the big breakthrough they had was they did use real knitted swatches in their data set, but they augmented their data set with simulated knitting that I showed you from one of those industrial knitting machines, one of those big Shimaseki machines. And so they figured out that by training the model on both the photo of the pattern and on the simulation of it, it gave them much better results. Now this paper, and you can read it online, it has a lot of calculus in it, most of which was right over my head. But from what I can tell from the conclusion, they haven't quite cracked it perfectly yet, but they're pretty close. They managed to get to about 80% accuracy in their experiments, and they use both convolutional and generative adversarial neural network scans. So I kind of read this paper and I was like, huh. So some very smart people using math I don't understand and machine learning I have no hope of understanding without a doctorate. They haven't been able to crack it. So I'm not going to crack it. But I actually found that kind of exhilarating. You know, I think this is one of the great things about being a beginner. Like, hey, my idea was a good one. Real scientists are actually trying to solve this. And I can just experiment and learn some stuff. No pressure. So I decided to cut my scope way back. Rather than I originally envisioned this as kind of an OCR problem, you know, of like character by character trying to understand the knitting. I decided to instead treat it as an image classification problem. So take an image as input and output a class label for it. You know, similar to how I can look at Mega's jumper and say, that's reverse stocking stitch. I wanted to build a machine learning model that could do the same thing. This is the plan as I saw it. Get myself some training data. How hard could that be? Label it. Train a machine learning model. Deploy a machine learning model. Maybe build a nice little front end for inference, you know, to show it off. And then dance on the grave of the knitting industry, right? You know, what could go wrong? Spoiler, everything's about to go wrong. Okay, step one, get myself some training data. Look, for anyone here who's brand new, the first thing you learn, the first thing I read in every article about starting a machine learning project is that getting clean data is the hardest part and where you will spend 80% of your time. And I thought, what? It's going to be easy. You know, so first of all, there has to be an existing data set, right? So I looked at those papers and what other researchers had done. So that nitpicking textures paper, the authors actually machine knit, measured, and photographed like 300 swatches from Stitch dictionaries and stuff. And they've actually made this data set available on GitHub. You can actually download it. This is what the images look like. As you can see, they stretched the heck out of them though. That was to help them work out how they fit together, to patch them together. And that makes them a little harder to work with, to work out the pattern. So I figured that might make my image classification difficult. So then I looked at the neural inverse knitting folks. They also made their data set available. So they started out, they extracted 12,000 patterns from one of those Shimaseki knitting machines, and they knitted a subset of about 1,000 of them in 5x5 grids. And to try and solve the tension problem, as I mentioned, where knitting is stretchy, they inserted steel rods into the grid. I thought it was pretty cool to lay them flat to photograph. But they realized really quickly that this just was not going to scale. So for the other 11,000 patterns, that's where they rendered them using the software simulator. And so you can actually get their photograph data set though, the 1,000 images. You can see some of the examples there at the bottom, but they're kind of just like little slices of designs. And I kind of just wanted to focus on basic stitches. So it wasn't really suitable for what I wanted either. And that left me with sourcing my own data. And again, overconfident. I'm a hand knitter. There's no way I was going to crank out 1,000 samples myself, but I do have a mighty knitting army on social media and on Ravelry. And so I decided that I would just source it direct from knitters, right? And so to make things as automated as possible, I started by setting up an email pipeline. I'm not going to go through this in detail, but the idea was I knew that I wanted to eventually get my images of knitting into S3, Amazon Simple Storage Service, our object storage service. And rather than have people send them to me and me having to upload them, I actually built a workflow here where they could send me an email, and I had some serverless processing through Lambda that would actually extract the attachments and save them in the bucket for me, and record them in a database so I knew where they came from. And this just saved me a lot of time on having to handle everyone individually. So once I had that set up and working, I put out the call. So this was the tweet I made in October last year asking for knitted samples. And I decided I was only going to focus on like basic stitches, you know, stockinette, garter stitch, seed stitch, and moss stitch. These are just 4 very basic. They're knits and purls. And I figure I'll limit my scope, right? Something I want to make sure I get successful. And so I wrote a really long blog post where I said exactly what I wanted, what I don't want. And I shared the email address, and I put this on Ravelry, and I shared it on social. And the good news is it kind of went viral. Like, it got retweeted like 350 times, and people started tagging their knitting friends. If you've ever read Janelle Shane, she has that AI weirdness blog. She retweeted me and messaged me, and it was like the highlight of my year. She's so cool. And the best part was that images actually started to arrive in the bucket. And I was like, oh, humanity, real human beings around the world, they're helping out my project, you know, they're being so generous. And then I looked at them and my face fell because they were human beings. And yeah, my plans got tossed out the window quickly. So I ended up getting about 400 images. And here is a sample of them. Yeah, so some folks sent in like finished projects, which are lovely, but didn't really have the resolution I needed to sort of see the stitch patterns. Some lovely lady on Ravelry sent me a message and said, oh, I've sent you several images. I may have also included a picture of Halloween candy because I couldn't figure out how to delete the attachment. Some people would just reply to me on Twitter with a bunch of links to Instagram, and no, I'm not going to go scrape them off your Instagram. That was the whole point of setting up the workflow. I got a Calvin and Hobbes comic. I don't even know what that thing on the lower right is there. So look, the first lesson is that crowdsourcing is a minefield. Even with the best of intentions, people are people. They get excited. They do not read. And I don't want to shame these folks. They were all being very generous with their time and trying to help me out. But yeah, crowdsourcing your data set, big risk. But what the hell, I persevered. I threw out all the dodgy images. I cropped all the rest to just show the stitch pattern. So I had my training data. Next, I had to get them labeled. And rather than do this myself, I again turned to my fellow knitters. AWS have a service that they announced at reInvent, I think 2018, called SageMaker Ground Truth. And that helps you build highly accurate training data sets for machine learning by coordinating public and private workforces. Basically, it's a nice UI for doing training data labeling. And so I put out a call, and I got a volunteer task force, and I set up my job. And if you haven't seen it, this is what Ground Truth, the interface looks like. And there's a few different options you can set up, but this is the way I did it. As you can see, a volunteer would look at the image, and then they had some options on the right to choose from. And you see, I've actually got a couple there. I put reverse stockinette because that's the back side of stockinette stitch, and a bunch of people sent me that, so why the heck not? And also other, which I thought would be my catch-all for anything that wasn't one of those. And I configured the system so every image would have to be reviewed by at least 3 people to minimize the chance of errors. And that turned out to be a really good thing because I quickly realized I had another problem. On the left here, you see garter stitch, which is when you just knit every row, no purling. And on the right is reverse stocking stitch, which is knit 1 row, purl 1 row. And they look a lot alike. In real life, they're very easy to tell apart because you can just flip it over and they're very different on the other sides. But in a photograph, a flat photograph, they're very hard to tell apart. Even I had a hard time telling them apart. And I realized pretty quickly my labels on that one were not going to be very trustworthy. 2 other stitches I included were seed and moss stitch. And I thought these were going to be very easy to tell apart because look at them. They look really different, right? And then I discovered that in British patterns, they use both words to refer to the same one, the one on the left. Only Americans call the one on the right moss stitch. So again, I have a bunch of labeled images that are completely unreliable, so I had to chuck those out. This is the end result. of my ground truth labeling job. You get your nice little labels. And I realized that with the limited data set I had, the unreliability of my labels, I needed to descope a little bit further. You know, rather than try and identify 5 different classes, let's just go for a single one. You guys have seen Silicon Valley, right? Like hot dog or not hot dog. I'm just going to build stockinette or not stockinette. That's what I landed on here, okay? Let's train the model. So there are a lot of ways you can run machine learning algorithms. You know, data scientists love them, love their Jupyter notebooks. My Python is pretty rusty these days. So I actually used Amazon SageMaker within the AWS console. That's our fully managed service. It covers the machine learning workflow. We've got a lot of tutorials and workshops on it. I'm sure Angus can run a detailed talk on it for you in the future. I ran my training jobs on a single P3 instance that has powerful GPUs to accelerate machine learning jobs. So I basically gave SageMaker all those images on S3. I gave it the output of the labeling job in ground truth, and I kicked it off. It took me like 7 tries to get a job that actually finished because I kept screwing up one setting or another because I'm a newbie. But eventually it worked. I got a model. I got a training job that finished. I got a model. So I needed to deploy it. And again, SageMaker, I'm not going to show this, but I can show you when we switch over to SageMaker. Makes it really easy to deploy and host your model in production. That was the simplest part of the whole project, to be honest. The endpoint just takes a few minutes. I killed my endpoint recently. I fired it back up this afternoon. It just takes a few minutes. And then you can start passaging images to it and getting classes back. And then to have something pretty to show off, I wanted a web front end. And fortunately, my friend Gabe Hollenby, he's an AWS evangelist in Singapore. He built a really nice little web front end, and he's got it on GitHub for a React app that does that. And so that's what I'm going to do. The only tricky bit, just to call out if anybody finds that and wants to use it, is that SageMaker endpoints aren't exposed to the public. So I had to set up a Lambda function as an intermediary. But anyway, I fired up the app. I pointed it at my endpoint. I fed in the first image, a close-up of stockinette stitch. And drum roll, please. Oh my God, stockinette stitch. That is actually correct. I have nailed machine learning on my first try. I'm clearly a genius, and where is my PhD? But I thought I better drag in a second image, you know, just to be sure. Well, crap. That is not, in fact, stockinette stitch. That is garter stitch. All right, well, all right, let's try a third one. Let's try something that's definitely not either of those. Well, that's not even knitting, that's crochet. And it's labeled as stockinette. So with a very, very sinking feeling in my stomach, I tried one last test. That's a cat. That is not stockinette stitch. Yeah, so cancel the PhD, no PhD for me. And so this is what I learned, that I got very depressed at this, but Aparna and Gabe and a few other people told me, with machine learning, it is very unlikely you hit the jackpot on your first go. Very, very unlikely. And when I went digging in my logs, I could see that my training and validation accuracy were 57% and 45%, basically a coin flip. So yeah, back to stirring the pile of variables. I ended up running more than 15 different training jobs, trying to find the magic combination that would give me the best result. So to minimize the effects of image size and color, because I thought that might be a factor, I cropped them all to a fixed size. I converted them to grayscale. I also rotated each image 90 degrees, which doubled my sample size, you know, meant I had a whole other set of images. I also learned about clutter and added that in. Clutter are, I added images of dinosaurs and accordions and airplanes, basically things that weren't knitting at all, to try and give more examples of non-knitting to avoid overfitting. I also ran a hyperparameter tuning job, which made me feel very fancy. And hyperparameters are just what they sound like. It's a bunch of parameters you can, you know, twiddle to try and maximize your algorithm efficiency. But the good news is that rather than trying out thousands of combinations, SageMaker makes it really easy to set up a tuning job that will just do that for you. It tries out like hundreds of combinations and figures out the one that gives you the best accuracy. So you don't have to stir the pile yourself. You can let SageMaker do it for you. So let's see what I ended up with. I am going to stop Keynote, and hopefully you can see I've got SageMaker open here. Just make sure I haven't been logged out. Refresh. So yeah, so just showing you SageMaker. You can see these were my labeling jobs in there that I did in Ground Truth. Tried a bunch of those. I'll show you briefly training jobs. If I click on that, you'll see a whole bunch. This was from the hyperparameter tuning jobs. It actually ran a whole bunch of them on my behalf. And some of them stopped, some of them it failed, basically trying them out to see which one was going to give me the best results. I mentioned endpoints. So here I've got the endpoint, which is what we're going to use in a moment for my web interface. And I'm going to open that up now. So this is actually my little Knitting ML inference app. And I've got a folder here of test images. So I am going to drag one of these. I'm going to start by dragging an image of stockinette stitch into the app. And hopefully, wait for it, stockinette. Yes, we have stockinette stitch, but I know enough not to trust this. All right, let's try some garter stitch. Drag in that garter stitch again. And this should hopefully be not stockinette. It's 100% sure that is not stockinette. I will now do that crochet just to prove that it again recognizes now that crochet is not stockinette stitch. All right, let's do the kitty cat because everybody likes seeing the kitty cat. Cool. And actually I'll drag in just a bunch more so you can see. I do have some colored ones here as well, so I can even do some of these too. These were actually people at a conference I was at. I ran around and took photos of their actual jumpers with my phone because that was kind of the original point. And so it doesn't get them, it's not 100%. There are still a few. There's even, I think, one of the stockinette, it doesn't get quite right either. Maybe it's that one. So if I scroll down here, so we've got, so stockinette's, this one here, the second one is actually not stockinette stitch. Oh, I've got to put that one in twice. Sorry. You can see why it would get it wrong. It's got stockinette stitch kind of has little V's, and you can see why that's probably the feature that it's picked up and decided that's stockinette stitch. It's not, I'm not sure what the heck stitch that was. It was an unusual jumper. And also this bottom one here, this black and white one is also, it is stockinette stitch, but it didn't pick that one up. And I'm wondering if it's because of the fuzziness of the yarn there. But all the other ones, if I'll drag a few more in, there's a seed stitch, there's some weaving, some more crochet, and it gets all of these. It's actually pretty accurate. And so if I switch back to Keynote, so this is my stats now. So I'm up to nearly, with 900 images, I'm up to nearly 95% on validation, which is pretty good considering total newbie here. So my next step with this and what I'm working on doing is expanding it. Obviously, I want to go from one class. I want to go back to doing multiple classes. So I'm going to go back to my training data and start cleaning up training data again, trying to get very clean images for all those other classes to work from. If you're curious, I should mention my total cost for this project, around 25 bucks US. And most of that was because I ended up running training jobs multiple times, like I said, because I kept messing it up, which isn't too bad, 25 bucks to get to there. So in conclusion, I am not going to be disrupting the knitting industry anytime soon. But between you and me, I reckon that some of those scientists are going to get there. We will have a knitting replicator within our lifetimes. I'm pretty sure of it. And to give some thank yous. The dirty secret of machine learning is that it usually involves at the start a whole bunch of human beings clicking a whole lot of buttons. So there were 53 knitters who actually sent in images to me. There were 14 of them who spent nearly 15 hours labeling them over and over and over and over. I don't know, I don't think you were involved, David, but you know, it's just really cool. There's quite a lot of knitters from around the world who helped out. And I also there, as I mentioned, benefited from my colleagues, Aparna and Gabe, who are great. So I hope this has entertained you. I hope has it inspired you a little bit in your machine learning journey. At the very least, I hope it's changed the way you think about traditional crafts like knitting. Just because grandmas do it doesn't mean it's not very geeky. But wait, there's more. I do want to just say before I go that we do have a couple events coming up that you might be interested in. Tomorrow, I'm actually helping out with this. We have Serverless Community Day, which is happening online. And it is, there's a URL there at the bottom, and I can share that in the chat as well. But mainly focused on serverless. I think there is one talk from Dr. Dennis Bauer at Cyro who's talking about using serverless in the fight against COVID-19. So I'm pretty sure she's going to be talking about machine learning there. But more specifically, with more machine learning talks is Just Plain Community Day, which is happening on the 6th and 7th of July. And I had a look, there's actually quite a few AI ML talks on that, and it's again going to be virtual. So you may well want to go. And that is pretty much me. So I am open for questions if anybody has any questions, and bear in mind that I will tag in Angus if I need to.
And so with that, thank you very much, Kristine. That was a very good presentation. It's
I went so long. Oh my gosh, I didn't realize the time. Sorry, went so long.
It's okay. It's a very good presentation, though. Learned quite a few things about actually knitting as well. And I didn't realize you could do ML on knitting patterns. So
yes, indeed. And in fact, there was Janelle Shane from AI Weirdness actually did a project called Skyknit, where she trained a machine, an AI to generate knitting patterns, feeding it a corpus of patterns. And a bunch of knitters from Ravelry then tried to knit those things, and you end up with some really creepy looking, you know, eldritch horrors. So that's another one to look up.
But yeah, it's an interesting field at the moment. It's with AI, what you can do basically. And I guess it's a nice thing to see so many people online, and I can't wait to see what they'll generate out of their, any ideas that they have that they can showcase in the future.
Yeah, I just find a lot of the basic tutorials you see for any new technology, I don't find them, I don't know about you guys, I don't find them very exciting to build a to-do list app or to just follow along someone else's, tutorial. I want to then solve a real problem or something interesting. And so I just always think if you're trying to learn something new, be it machine learning, be it a coding language, like solving a real problem that you're interested in and invested in the outcome will motivate you and just make you a lot more likely to actually learn it. All right. Well, thank you, everybody. I had a lot of fun.
Thank you.
Thank you very much for your presentation.